Hello everybody, I will start my today another coding practice. So today I will solve this question again. Yeah, following yesterday's two videos. So this is the word search 2, and yesterday I solved this question firstly with backtracking. Yeah, recursion with backtracking. And then I solved this question with dynamic programming. But in the recursion with the backtracking solution, it was time limit exceeded, and the dynamic programming solution, it was memory limit exceeded. So I had to find a better way to solve this question. So that was, the two videos I posted yesterday. And the video, I will, tell you how to optimize solution and implement it. And I actually read the solution of this question. So the answer is in my head. So yeah, that being said, I will try to explain, as clear as possible, and then I will start the implementation. Okay, so firstly, I will talk about the question statement. Yeah. So in this question, I'm giving n by n bold of characters. So each cell has one character. And also I'm giving the list of words, list of strings, and my task is to find each word in the words list. And if I can find it, I will return. And what is expected to return from the method I will implement is the list of words which are found in the bold. And the order doesn't matter. Yeah. The the words doesn't have to be sorted in the order which was given with the words. Yep. And also I had to take care that okay. And when I try to find the word, it works in this way. So when I need to try to find the word oath, I can search from anywhere in the grid, and from the first cell, I will try to move vertically or horizontally. And if I can find the second word, character, which is A, I will go that way. And one thing I have to note is I cannot visit the same cell twice in a single word. So I cannot go back like OA and then O. So OAO is not found in the board. Okay, so that was the question. Yeah. So let me introduce the optimized solution. So the idea is that the problem, for the backtracking is that, okay, so in my yesterday's solutions, what I did was basically for each word, I try to see if the word is included in the board or not. Yeah. So, yeah. For each word, I try to search. I try to do the backtracking. And the problem here is that, yeah, maybe the word I'm looking for is like, okay, I will reset the implementation. Okay. So for example, if I'm looking for say AA, ABAB, 3, and C and DEF. So in those cases, yeah, even though I moved until, I tried to search until AB in the board. And so when I'm searching for ABC, then I will visit next C. Then that's the end. And for ABD, I started from the beginning of the string. So I started again from the first A, and went like A, B, A, B, A, B, and D. Then for the next word, I started from the beginning again, and I did A, B, A, B, A, B, E. So there are so many redundant words I did in this case. So in my state solution, I'd like to avoid that. So for that, what I can do is using a try. So when I see these four words, what I can, okay, let me make it a bit shorter. Yep. When I see these words, I can easily find that ABAB is, common. The same, shared prefix. So what I can do is try to avoid the traversal for this common suffix. So I will build the try in this way. Yeah. And in that way, okay. So firstly, I try to find from the bold, that's the traversal from number first. So let me think of this cell to find something. Okay, let me add one more thing. So let me say I have one more try. Oh, sorry. This whole structure is the try, but let me think. I also have the words like xyp, xy cube, xyr. So in that case, what I should do is you know, I start from A and go to A B A B D or something. Yeah, that's what I'm looking for. Or I'm also looking for firstly X, then Y, then P or Q or R. So for example, if this, I try to find the reversal, word search from this cell. So for this cell, for example, this is A, I should start from here. Yeah, so I should keep going. However, say this is, for example, R. In that case, I don't have to even start the word search from this cell because R is not included in any words I'm giving us the list. So that's what I can use, to optimize the search. So for every cell, I will start the, traversal, but I should keep the traversal, word search, only if that, the characters I visited is used as any of the, I mean, the, string I visited so far is included as a suffix in any word in the words list. So only in that case, I should continue the traversal. And I can use the backtracking for the traversal. Yeah, so that's it. And I can find the constraints or the strings where they're unique. So once I find the, word, I can just forget the word. For example, if I say, if I find ABABC, yeah, let me show it a bit more easy way. Let me think of this example. In this case, say if I find, sorry, if I find XYP first, then I don't have to search for XYP or even XY. So I can just delete this P and Y from the try because I don't have to search for it anymore. And then from the next, if I find XZ or XZR, I it's happy for me. But if I find XY, then I can stop the word search at that moment because XYP is not needed anymore. Okay, so that being said, I will start my implementation. So the first thing I will do is but for this, I mean, if I find the word, then I can forget the, that passing the try. Let me do this as the optimization. So let me please let me forget it first. Okay. So firstly, I will build the try of the words. Yeah. And next, I will start the iteration. For each word, I will start the backtracking. Yeah. So okay, with this, so okay, so this is the main method. So firstly, I will build the try, and then for each word, I will try to find the word. And yeah, wait, no, sorry, I'm doing something completely wrong. I don't have to iterate for each word because actually that's what I wanted to avoid. I don't do that. Instead, I will start from any cell and try to see if I can find the word. I will try to search the word as much as possible. Yep, that's it. So for each row and column, I will start the um I will try to find the word. So okay, so for let me say okay, let me do this in this way. So this search, returns the list of found words. Yeah. So in this way, I will append, add the words in the list to found words. Then finally, I will return found words. this way. Hmm. So I think this is what I can do. Oh, actually, my microphone is not enabled. Oh, maybe. Okay, so how it works. Hmm. So let me start the implementation from here. So as I said, I will use the backtracking, and I think I need current cell and also visited cells. So visited cells should be the set of, you know, tuples like this. Yep. Okay. So now I will implement the recursive function search. Oh, and I think I also need where I am in the trie. Yeah. Actually, I need only current node. Yeah. So this is good. Sorry, let me say. So okay, let me implement trie first because I think this completely depends on the implementation of the trie. I cannot skip it actually. Okay. Yeah. So this is it. And also I need to register a new word. So I will implement this. Wait a minute. Yes. So okay. So this is how I can register the new word. So yeah. Then also what I need is, yeah, maybe so far with this traversing, I will have the pointer to the node in the trie, and I mean move the node from the find words method. So I don't do it in the instance method. Okay. Yep. So this is how I initiate the try. And as I said, for each node, I will start from the the current char is this. So if so try.children is try is actually pointing to the pseudo node. Yeah. No. Try is actually try.root is the pseudo node. So this is how I can see the first character. Yeah, is in the try. If not, I will continue. And if it is, I will try to find from this node. The current node should be try.root.children. Then current char. Yep. Let me just name it in this way. This is the first node. And the current cell is row column. Yes. And visited cell is like this. Yes. And the bold should be, yeah, just the bold. Okay. So now I will try to find the word, any word in the try. So the next char I'm looking for is current.children.keys. There's the next word I'm looking for. Then and for each, I will see. Okay, let me change it. I will think of the next cell. And then for the next character, I will see if it is exists as the children of the current try node. Okay, so here it is. And first thing I have to check if this cell is out of the board, I will just skip it. Okay. Then also, if this next chart is in the visited cells, I have to skip it. Otherwise, and also if next chart is not doesn't exist as the current node children, then I have to skip because I don't have to. It doesn't worth searching anymore. Yep. Then in here, it worth visiting the next cell. So what should I do? So I mean, I should say current node should be. I mean, this is the next node. Yep. And also, next cell should be obviously next row, next cell, next column. And visited cells should be appended by. Okay, so I decided that current cell is already in visited cell. I will make it a rule. Yep, so I will do it. Then I will call the search method. Oh, but if next node ends with here, then I can say I found a new word. So one thing I forgot to do is in the trie structure, in each node has its attribute. This is important because without this, I cannot find which node is the end of the word. They're like I have AB and ABC and ABCD, all of them. In that case, AB, when I reach there, it means that I've found the word AB. And also, if I keep going and then reach C, then it's also ABC, which I'm looking for. So I have to mark if is end to each node and say if I visit A B and then B node has is end is equal to true, then it means that I found the AB word. Okay. So I can do it in this way. Yep. Okay. And wait a minute. So once, okay. So if the next cell ends with that, I have to build the word and append it to the found words. So let me change this found words to the instance variable so that I can append found words in each recursive function. Yeah, when I find it immediately. I think it's more easy to understand. So I don't need this. Okay. So here I will append self.found words append, and here I have to pass, build a new word, but currently it's not impossible because I have visited cells, but I don't have pass software, child software. So let me change it to child software. This is, I think, one of the optimization I can make later. I think I also should have the child software list and child software set so that I can, yeah, find it easily. No, sorry, so that I can check if in line 81, no, line 77, I can find if the node is already visited or not in the constant time. And I think one optimization I can make here is that I think child software and child software list, and also maybe both should be the instance variable so that I don't have to pass it every time I call the recursive function. So let me do it. And I have child software set and child software list. Here I will initiate it. Yeah, this is it. That being said, I don't need these two arguments and also both. Okay, this is it. So here in line 78, this should be self dot child software list, no, child software set. So if it's already visited, then I have to skip it. And in line 81, yep, this is good. Okay. Okay, so now in line 89, what I can do is okay, so firstly, before thinking of line 88, I will append this next cell and next node to the child software set and child software list. No, wait, I need child software list, but I need sales software. Sorry, sales software set. Yeah. So here in line 85, I initiate next cell, and this should be next char. Oh, this is next node, and next char should be this. Okay, and I will call. I mean, if I will append these to these two data structures. So cell software set should have now next cell also. And also child software list should have next char also. Then if next cell is the end of some word, I found the word which is generated by concatenating the child software list. So I will append it to the found words list. Okay. Then in line 96, yeah, this is not necessary. So I have to keep going with this node. I will close the recursive function. So as I said before, for example, in the case of AB and ABC, these are new words I have to search for. In this case, even if I find AB, I still have to keep searching for ABC. That's why I close the recursion here. And a kind of termination point or base case, I can say, like ABC is that like in the case of C node in this example, it doesn't have any child. Yeah. So in line, wait a minute. Yeah, in line 82, in that case, this is false and I finish the search anymore. I don't do the search anymore. So that's how I stop the search. So I will call with next cell and next node. Yep. And after that, I need to load back the changes I made onto these two data structures for backtracking. Yep, this is it. I think I've implemented all the necessary, code. So let me walk through my code quickly. Firstly, I implemented try and also node, which is used in the try. And in line 40, this is the main method. So I first initiate the try and register each word, the try. And I made board and found words, the instance method, so that I can access it from anywhere in this class. Yep. Okay, good. Then in line 49 and 90, so 49 and 50, I traverse each cell and I will think of it as the starting point. So let me change one thing. Let me call the search method before adding current char into the yeah ma- sales of or set or sets of a list. Yeah, I think so. What I mean to say is I initiate this as an empty data structure, and I don't have to think if current char exists in the try to root the children. And the first node I will be the pseudo node, and the first cell should be row column. Yeah. So I call it in this way. And I don't have to think of current char here. So if I do this, what happens is that when this search method is called, it is saying I try to visit current cell. Yeah. And also I'm and I'm looking for the corresponding node, which is the children of the current node. So what I can do here as the base case is so this is the current char. And if this current char is not included in the children, in that case, I can just finish. I can just return. Yep. And if it exists, I move down to that node. So current node. So this should be previous node actually. Okay. This is how I can move to the current node. So now current char exists. Wait a minute. So current char. Yep. Okay. So I can say current char is the word, one of the words I'm looking for, one of the characters I'm looking for next. So I move the try node. Now current node corresponds to the current char. And what I can say is if current node is end. Oh, and also in this case, I will append this node and character to the two data structures. Yep. Then if this is the end, I find the word I'm looking for. And I will append it to the self to the found words. Okay. But as I said, I will keep going. Okay, so now I can find each next row, next column. And I will make sure that I mean, I will do the validation if the next cell exists in the boat, not in the Cori, but in the caller. I will do this and this. And also I will do this validation in the caller. Yeah. So I can say must be in boat, and I have to make sure that not visited yet. So these are two things I will check in the caller. So once these are confirmed, I will call the main method. I mean, call this recursive function. In this way. Okay. Oh, and I have to roll it back. So the rollback should be done before finishing this method. It should be like this. Okay, so now let me, oh, sorry. And I have to, pop out this and this. Okay, now let me execute my code. Try object has not been read. So this is typo. So current node is not associated with the value. I see in this case. So in this case, I have to return as I said. Oh, sorry, no. Current, okay, sorry. In this case, I should return, and otherwise I move the current node. It defines the current node. This is typo. And this should be, oh, I don't know why, but this is calling it twice. Okay. So since like the word, any word is not found. So let me check how much I've found. So I find O and finishes it, E and finishes it, R and finishes it. Why is it? Because the try is wrong or traversal is wrong. So let me see. Wait, I think this isn't previous node, but current node. So, okay, before fixing this, let me quickly fix something. I think this should be current node. I think it's more easy to understand. I don't have to. I don't have a reason that only for node I pass the previous one. So here, so for that, I will check if the word exists in the try before calling it. Like this. This is how I get the first node. Let me put it here. Okay. But I don't append this yet to the two data structures. So in line 69, I don't have to check this. And I don't need this. Yep. And because this, I visit this current cell char, I append it to the two data structures. Then in line 73, I check if current node is end or not end. If it is end, then I will build the word and append it to the found words list. Okay. So in line 88, I initiate next row, next chart. This is okay. And also, as I said here, I will. So as I can see from number 3, I have to check if next char is in, I mean, included as the children of the current node. Oh, let me just define the char is this. Yep. Okay, so this is how I can do it. And cell sulfur, I added row columns. I remove it as the rollback. And for child sulfur list, I have to pop out the element which I added last. So row column, it says it's not added yet. Ah, wait. Where is it? Because row column is added here, but it says it doesn't exist. Did I update row column? Or maybe this is removed already in the query method? Hmm. And I don't return anywhere. So I'm not pretty sure why. So how can I do it? Okay, wait a minute. So maybe I can do some. I will print X here and row column in this way. I think this is good. I will check this and this. In the end, I find that the cell is somehow empty. A, B. Wait, am I visiting the same cell twice, maybe? I think it's possible. Let me print it out. Oh, seems 0011 then 00. Yeah. I don't know why, because from here. Wait, why 00211? Because it goes diagonally. Yeah. Reach 00 and reach 1. I see. So probably I guess I couldn't find any word from. No, 00 is. This is reach word, and this is child software and current node dot bar. Wait, current node dot bar is seems to be A, not O. Why is it? Because first char is O. No, sorry, this case. So first char is now A. So this is okay. And now I reached current cell, which is 0, 0. And sorry, so child software set should be 0, 0. Yes. So this is okay. And I visit 1, 1, which is B. No, this isn't 1, 1. Why 1, 1 is visited here? Oh, sorry, next column. This should be next row. Okay, now it's accepted. Let me submit my code. Wrong answer. Seems flag always is written twice. Yeah, in the case when, I find two always somewhere and somewhere, I have to deduplicate them. So my, approach I can avoid it is, so I initiate found words with not list but set, and I add the found words to the set. In that way, I can avoid the duplication. And in the end, when I return, I convert the set into map, set into list. Okay. Let me try it again. I submit it now. Good, accepted. Okay. So I finished my today's practice with this. So in this video, I solved the word search too. And yesterday I solved this question with first three with recursion with backtracking, which ended with time limit exceeded. And I tried to solve this question with dynamic programming, which is recursion plus memorization, but it ended up with memory limit exceeded. So in today's video, I used the optimized approach. The optimized approach is to use the trie for the search words. So the main problem I experienced in yesterday's solutions was that I had to, I tried to search the word, each word independently. but in that way, I did so much duplicated works. For example, in this case, I don't have to visit ABAB again and again if they're common between or among multiple words. And so, up to avoid this, I firstly build a trie from the words I'm looking for. Then, from each node, each cell in the grid, I do the traversal, basically the recursion with backtracking. And yep, every time I visit a new cell, I move the node. I mean, I move the trie. So I move the current node pointer in the trie. Yep. So in that way, I sync the move in the, traversal in the cell with, I sync it with the traversal of the nodes in the trie. So in that way, and in that way, if I reach the, if I find that the, okay, in that way, I can do two things. Firstly, I can stop the traversal once I find that the string I visited so far is not included as the suffix of any verse in the verse list. In that case, I can stop the traversal. And also, number two, the benefit number two is that um, I I can find if the traversal is ended or not by looking at the current nodes is end attribute. Yep. And also the benefit number three is that obviously, as I said, once I visit, say, ABC in the trie, and if the C has D, E, F childs, I don't have to start them from the beginning. Yeah. So that's another benefit. Those being said, this backtracking plus I approach, with this, I can find the words I'm looking for. Okay. And as I said, one optimization I can make is that if I find the word, and if I find that there isn't any word, which, there isn't any word I'm looking for, which has the current words as a suffix, I can just remove that node from the trie. And also, if I remove that node from the trie, and if the parent node, everything is a parent node, and if that character is included only in the remaining, only in that removed string, then I can also remove that node too. So that's how it works. And in this way, I can, makes the trie smaller and smaller. So I don't have to, do traversal for the string which is once found. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.